All right, so we want to continue looking at exponential functions, and in particular, we want to look at some points associated with exponential functions, and from those points that the exponential function will go through, we want to figure out the equation of the exponential function. Okay, so the exact instructions are to determine the equation of the exponential function associated with the following points. Okay, so what do we know? We know exponential functions take on the form f of x. Okay, I guess I'll do this in green. F of x equals c times a to the x power. Now, basically, there are two things you have to find here. You have to find the c, so that's kind of your first step. And after you find the c, then you have to find the a, the exponential base. So the c is going to be the y-intercept. The y-intercept. So the y-intercept is what you're trying to find here. So we're going to focus in right here, 0, 5. So the y value is 5, right? 5 is the y value. So I'm plugging this in here. So the y value here, the f of x, is 5. That equals c times a to the x. What's x here? Well, x is 0, right? X is equal to 0. So our y value is 5. That's what I'm plugging in for f of x. And our x value here is 0. That's going to give us 5 equals c times, well, what's a to the 0 power? Anything to the 0 power is 1, so we get c times 1. In other words, c equals 5. Now, that's a formal way to do it. The quick way to do it is just see, basically, okay, what is the x-intercept? That's what the c is, right? C is the x-intercept. Well, the x-intercept occurs at x equals 0, so it's just 5. So you just have to see when x is 0, y is 5. So that's the quick way to do it. You can just say, right there. That's my c, okay? So I'm going to get rid of some of this here. I'm going to write that this is, so we're going to go down one more step up top here. F of x, so we're going to replace the c here. The blue c, we're going to replace that with a 5. So we have now 5 times a to the x. And now I've got to find the a. I'll do this algebraically first, and then I'll show you the quick way to find the a. So what I'm going to do, I'm going to start back at my, come on, don't do that. I'm going to start back here at my y-intercept. Come on, don't do that. There we go. 0, 5, right? This is my y-intercept. So I'm going to go 1 forward. I'm going to ask the question, how much do I have to multiply by to get from 5 to 10? 5 to 10. That's kind of the short way to do it. And you say, to get from 5 to 10, I had to multiply by 2. That'll be your a. That's the quick way to do it. Now I'll show you the formal way to do it. The formal way to do it is, okay, let's take this point right here, 1, 10, right? 1, 10. The x is 1, the y is 10. So in for the y, the f of x, I'm going to plug a 10. So I got 10 equals, we already know c is 5 times a is unknown. And x here is 1. So I basically have 10 equals 5 times a. And I basically divide both sides by 5 here, right? The 5's cancel, and I get a is 10 over 5 or 2. But that's a long way to do it. The quick way to do it is just figure out when I go one step forward from x equals 0 to x equals 1. So you're only allowed to move one step on the x. So if I move one step forward from 0 to 1 on the x, how much am I multiplying by to get from 5 to 10? Well, I'm multiplying by 2. And that's the quick way to do it. So as long as your x is only moving 1 forward, then it's easy to figure out the y. You had to multiply by 2. So I don't know. Let's just see if we can see this all the way through. So notice the x's up top, right? The x's are all moving come on, don't do that. The x's are moving forward by 1, right? Plus 1, plus 1. The x's are moving forward by 1, plus 1, plus 1. Now figure out what the y's are multiplying by. If you go from 5/4, make that red, to 5/2, to get from 5/4 to 5/2, you had to multiply by 2. To get from 5/2 to 5, you had to multiply by 2. To get from 5 to 10, come on, this is changing on me. 5 to 10, you have to multiply 2. To get from 10 to 20, you have to multiply by 2. So every time you're multiplying by 2, and that's what your a is. It's your exponential base. So we're going to replace the a with a 2. So we get f of x equals 5 times 2 to the x. And that's our function. Or you could say y equals 5 times 2 to the x. It's another way to write it. You could write y rather than f of x. Okay? Okay, so let's do another, number 2. Oh, let's go ahead and graph that one. So I didn't ask to graph it in the instructions, but let me show you how to graph this, a quick graph. This is going to be a quick graph. It would be helpful, I think. I'll show you how to graph these exponential functions quickly. So basically what you want to do the quick way to graph these, there are lots of ways to graph these, but the quick way, first of all, is find the x-intercept, right? The x-intercept, which we already have, right? It's 0, 5, or x equals 5. And that's also the c value, right? Right here, the c value right here is 5. And then you pick out one more point. We'll pick out the second point of 1, 10. So this is another point. I'll call this additional point. So at x equals 1, y equals 10. And then you have to remember that there's a horizontal asymptote for a typical exponential function, one that hasn't been shifted anywhere. Later we'll do some shifts, but there's always a horizontal asymptote at y equals 0. So those 3 things are all you really need to graph a exponential function. You need the x-intercept, you need one additional point, and then you need the horizontal asymptote. So first I'm going to put down the horizontal asymptote here at y equals 0. Let me put it in green here. It's my horizontal asymptote. I take my x-intercept at 5, 1, let's go 1, 2, 3, 4, 5, like that. That's also called the c value, which is at 5. And then at x equals 1, we're going to be up at 10 on the y. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And we'll connect those 2 points. And we know it's increasing to the right, so therefore it must be decreasing to the left, and it must be approaching the asymptote, the horizontal asymptote. So that's a quick way to do your graph. I'm going to write this as 1, 10. I'm going to write this point back here as 0, 5. So you want 2 points. You want the y-intercept, one additional point, and you want the horizontal asymptote as well as the basic shape of the graph. That's a quick way to really graph these. So just really need two points in the horizontal asymptote and the basic shape. That's all you need. Okay, so we weren't asked to graph that, but I decided to do it anyway. Okay, let's say I have x and y. X is -2, -1, 0, 1, and 2. Y is 16, 8, 4, 2, and 1. Okay, so we're told this is an exponential function. We need to find its equation, so we know it's of the form f of x equals c times a to the x. It's a time symbol. That dot is a time symbol. A is red. So I'm going to find out the c first. Let's find the c. Find c. So how do we find c? Well, the quick way to find c is look here at the y-intercept, and the c is going to be the y value at the y-intercept. So c is going to be 4. It's a really quick way to do it. Now let's find the a. Okay, I'm going to go back up top. I'm going to rewrite this. This is f of x equals, I'm going to replace the c with the 4. I'm going to have 4 times a to the x. So now we have to find the a. So what I'll do, I'm going to take the next point, which is 1, 2. So x is 1, y is 2. So I'm going to plug in for the f of x, or the y, I'm going to plug in 2 equals 4 times a, and x we know is 1 here. Okay, so in place of the f of x, I put a 2. And in place of the x, I put a 1. And I'm going to solve this, right? So basically, we got 2 equals 4a. To solve for a, we divide both sides by 4. The 4's cancel on the right. We get a on the right by itself. 2 divided by 4 is the same thing as 1/2. So a is 1/2. That's one way to do it. That's the kind of long way, but if you're clever, you can see. If I start back here at 16. So notice the x is moved forward 1 every time. 1, 1, 1, 1. So as long as the x's are moving forward 1, you can use this trick. Figure out what the y's are multiplying by every time. So from 16 to 8, I multiply by 1/2. From 8 to 4, I have to multiply by 1/2. From 4 to 2, 4 times what gives me 2? 1/2, right? How do I get from 2 to 1? I have to multiply by 1/2. So every time as I go from step to step to step on the y, I have to multiply by 1/2. So you can see, yeah, a is 1/2. So we're going to write this as f of x equals 4 times, in place of a, we're going to put 1/2 in parentheses, and then an x out there as an exponent. So that's it. That's your function, your exponential. Or if you wanted to write it as y equals 4 times 1/2 to the x power, you could write it that way as well. Difference is f of x versus writing y. They mean the same thing. Now, let me graph this real quick. So if I wanted to graph this, basically you need 2 key points. So this is not going to be to scale. It's okay. Things don't have to be to scale. Okay, no. I'll actually make this one to scale. What the heck? What? All right, we're back, I think, yeah. It's garbage. iPad garbage. X-axis and y-axis. Okay. So really the two things you need the x-intercept. Why I call it an y-intercept. I called it an x-intercept before. It should be a y-intercept. And we know the y-intercept obviously is 0, 4, or y equals 4. Did I call it an x-intercept before? Yeah, I did, didn't I? It should be a y-intercept. I don't know why I called it an x-intercept. That should be y equals 4 back there. Or y equals 5. Okay, y-intercept here is 4. Okay, yeah, y-intercept here is 4. Right, because 0, 4 is a point. And then we're going to take an additional point. Additional point is 1, 2. at x equals 1, y equals 2, and then what else? We need a horizontal asymptote, which we know there are always horizontal asymptotes at y equals 0 for a standard exponential function. So I'll start off with the horizontal asymptote here at y equals 0. It's just the x-axis. We're going to plot a y-intercept of 4, 1, 2, 3, 4 right there. And then a point of 1, 2. We can see this one's going to be decreasing from left to right. So it approaches that horizontal asymptote on the right. On the left, it just goes up. I'm going to write in these points 0, 4 and 1, 2. Okay, I'll just do one more. This last one will be a little more challenging. So I have my x's, I have my y's organized in a table. For x, we have -4, -2, 0, 2, and 4. For y, we have 80/9, 40/3, 20, 30, 45. This one's going to be a little more challenging. Okay, so we know this is exponential, so it's f of x equals c times a to the x power. So we can easily find the c. The c is essentially just the y-intercept here. So when x is 0, y is 20, so the c is going to be 20. So we'll plug in a 20 there for c. So we're going to have f of x equals 20 times a to the x power. Now notice that the x values here, they don't move forward by 1. They move forward by 2. So we can't just ask the question, what do you multiply by 20 to get 30? What do you multiply by 30 to get 40? You can't ask that question. So that won't give you the answer for A. What you have to do the algebraic method without just figuring out what multiplies at each turn to get the next number. So let's find A. Let's use a little algebra, which we've done. So I'll take this second point here, 2, 30, okay? So when we have the point 2, 30, the x value is 2, the y value is 30. So in place of f of x or y, I'm going to write a 30. You get 30 equals 20 times a. A should be red. And in place of x, I'm going to put 2, right? So here x is 2 and y is 3. So now I have to solve this for a. How do we solve this for a? Well, first we have to divide both sides by the 20. 20's on the right will cancel. So we'll have 30/20 on the left. 30/20 reduces to 3/2. So we get 3/2 equals a squared. Then you have to take just the positive root here. Just the positive root. Because a is only allowed to be a positive. Remember, a's are only allowed to be positive. So a has to be the square root of 3/2. So I'm going to replace the a up here with the square root of 3/2. So we got f of x equals 20 times the square root of 3/2 raised to the x power. There's our function. Now if we wanted to graph this, you need the y-intercept, which we have. We need an additional point. And we need the horizontal asymptote. And that should be enough to graph. So the y-intercept, remember, is 0, 20, or we'll say y equals 20. The additional point we'll get when x equals 1. What's y? No, at x equals 2, y is 30. So 2, 30. 2, 30. Right at x equals 2, y is 30. And we have a horizontal asymptote of y equals 0. So if I graph this out, this is not going to be to scale. We're going to have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32. Okay, I have enough. And I'll do here 1 and -1 and 2 and -2. So we're going to start off with I'll put my y-intercept down first. I'm sorry, my horizontal asymptote down first, y equals 0. Then I'll put down my y-intercept, 0, 20. Where's 20 at? 16. 20 would be right here. Okay, so I'm going to put a blue point there. That's my y-intercept, 0, 20. Then I have hold up, I didn't do this right down here. -1, 0, 1, and 2. Okay, got to get my x-axis right. So now we want to do 2, 30. 2, 30. 2, 30 would be... about here. Okay, so we got 0, 20. We have 2, 30. So as we move to the right, we're going to be increasing, and as we move to the left, we're going to be decreasing towards the horizontal asymptote. Something like that. All right.